Promise this survey or this presentation will not have as many wordy slides as yesterday. I know it's pretty hard. You've all got full stomachs now, so I'm watching you. I'm watching you all. All right, so this is a program that was been alluded to a couple times yesterday. It's funded by the Department of Agriculture and Water Resources. Basically, it's to try and gain more information to help inform biofouling management and development of the appropriate policies. So what we're trying to do with this program is to develop the appropriate amount of background information that we can help to use as a toolkit for indicators of whether or not the vessel is of particular concern. All right, so biofouling, okay, we've talked about it for a bit. We know that the pathways are very complex. They are frequently very unpredictable. You've got vessel-to-vessel transfers, vessel-to-infrastructure transfers, infrastructure to recreational yacht transfers. All sorts of things are happening. So it's incredibly complex, difficult to deal with. We've got commercial vectors, we've got recreational vectors, we've got the obviously private vectors, all sorts of things. Regulation, as we've been talking about, it's highly variable between different locations. So what's happening in Washington State is what's different happening in Hawaii, what's different happening in Indonesia. The nice thing is, though, is that there seems to be a lot of movement towards promoting the IMO guidelines for biofouling management, and that's great. And also, as we pointed out a couple times yesterday, this risk is integrative. So we're talking about risk from multiple ports, multiple bioregions over a longer period of time. That's right, so how do we deal with this? Well, we understand the risks. Of course we understand the risks. We've done a lot of studies, particularly in Western Australia, on resource sector vessels. I mean, ask Marion or Justin how many reports they've looked at over the last 5 to 10 years from ships that have been inspected. I mean, hundreds? Would there be hundreds? One or two? So there's a lot of information out there for those sorts of vessels. We know that recreational vessels have been surveyed around the world in different jurisdictions, so there's a bit of information there. So what about these commercial trading vessels? Well, we know that there's some good surveys done in the sort of mid-2000s over New Zealand. There's been some done over on this side of the wood as well, plus overseas. So what we want to do is we want to get a handle on these commercial trading vessels. So that's going to be our focus. This particular picture is a tourist trading vessel. So tourists, cargo ships, and it's all the same really, it's just a ship. And you can hear the kickback. Oh, my ships move really quick. They're only in port for a short period of time. We keep the bottoms really, really clean. There's no real risk here, is there? No. And what do we deal with? How do we deal with the idea that some countries might have very stringent regulations, and then another country might come along and say, well, that's actually, those regulations are an impediment to trade, so I'm going to pop up a WTO trade complaint against you. So all these different things are going to have to come into play. Who's going to cost it? Basically, we need more information. Scientists always want more information, I've got to say that. So we've got these 7 projects were released by the department last year. I think it was in May last year, it might have been April. Fairly short turnaround for getting proposals together. It was basically surveying international vessel arrivals in each of the states plus the Northern Territory. And the focus was really to characterize the broad nature and extent of fouling communities on these commercial vessels overall. And the original proposals that went in, the original discussions were, we'd look at a wide variety of vessels. We'd look at commercial vessels, we'd look at vessels in dock, in water, we'd look at recreational vessels. But in working through the program, we decided to really focus just on these commercial vessels, these large, greater than 300 GRT vessels. And again, we're trying to inform development of policy and regulation. So the projects themselves, what were we actually doing? Effectively, we were working with vessels of opportunity. I'd say that Ollie and Don over at Cawthron would know from the project that they talked about yesterday, getting a ship operator to commit to allowing divers underwater to look at their ships, it's really hard. If it's not an absolute requirement that's placed on them, there will be 1,000,001 reasons why they're not going to do it. So you really have to take advantage of any vessel that will actually agree to be surveyed. You gotta say, yes, I'll take that. So we did have some selection parameters though. We only wanted to look at international vessel arrivals. We only wanted to look at those vessels that had arrived really within 5 days of port arrival or port entry. So really a fairly short window of time that we were looking at. Now ships, just like the study that Ollie mentioned yesterday, these ships would submit a vessel husbandry and voyage history questionnaire as well. So there'd be information around what's going on in the background of that ship as well as the dive survey that we would actually do. And that questionnaire was available either online, or they could have a hard copy, or they could have a PDF version which they could fill out on their computer. Images and video captured by divers, so we've been talking about this before as well. Information from the vessel questionnaires and the dive surveys would then be collected and collated, and we'd be analyzing those together, and I'll talk a little bit about the preliminaries of that today. So the voyage history and maintenance records, again, it was all available online, and the online tool was great. So they could pop online, populate this thing with a whole series of drop-down menus, take about 15 minutes to do. They'd submit it. I would get an email. That's the center picture in the middle. I'd get an email instantly saying, okay, this vessel will come in. They provide a PDF document for me as well, so I could get all the information right into the database really quick. Everybody went for the PDF versions. They didn't go for this. So I'd end up doing all the data manipulation and putting the information in. But that's fine. We still got a good chunk of information from these vessels. Image capture themselves. So we built a camera rig, which we're using. It was really important for us to have, comparable pictures from one image to the next. We're going to be working in 7 different states, so we had to have some sort of way of standardizing image collection. So we came up with basically a stainless steel frame, mount a GoPro on the top. We had lights on either side of it. And the nice thing that we'd seen yesterday is that you get these little tags inside here. They've been used before. Just basically they're stock ear tags. Put the name of what you want, rotate it in. If you don't want the other bits in, just move them out of the way. So you can basically take the photograph, you've got a nameplate on the side with the vessel name, the date, the location, rotate in the tag you need, hopefully taking care of some degree of standardization with it. It's an easy thing to actually prepare, so if anybody wants to look at the frame afterwards, that's cool, just take a look at it. Okay, you saw this image yesterday as well, and variations on it. Basically, these are all the different areas that we were looking in. So we break up the vessel into bow and midships area and stern. In each of those 3 main areas, we would do a vertical transect along the side. Take a photograph just above the waterline, just under, a meter down, halfway down, and on the bottom. The purpose of taking all those is to get an indication of that, general level of fouling on the hull of the vessel itself. And then you would look at the different niche areas that are listed up there. And there's actually even more than that. Initially, when we started off, everybody had, all the inspection teams would have an inspection log, something like this, which I recommend. You can't actually see any of the words. Basically, it's locations on the hull. We would record what organisms we saw to very broad taxonomic groups. We record the general fouling loads as well. Now we found fairly quickly, and on the other side there'd be a little ship's hull diagram. We'd be able to jot in notes. But what we found fairly quickly is that filling out this form turned actually to slow down the whole process of doing the inspection itself. Now, a lot of these vessels are coming in and they're turning around really quickly. So a container ship or a ro-ro will come into Brisbane or Sydney. It's turning around basically in 8 or 9 hours. So we've got a very short window of time. We can't actually slow down vessel operations at all. So we weren't using that in the end for actually sort of recording data. We're going in afterwards and we're just looking at all the images that we would collect and then add all the information on fouling loads. And fouling analysis, so there's different ways you can do it. Obviously you've got the levels of fouling on one side, so there's the nice little level of fouling series that we've seen lots. There's also the fouling ratings analysis from the Navy, which has been talked about a few times. I don't need to spend much time on it because I've seen it. Okay, so we know what we're going to do. Easy, great, so we can collect the data. All we have to do is let people know that we're doing the survey and they'll come flocking to us because they all want to help. Never that easy. The department put in quite a bit of effort in terms of advertising amongst the marine community what was going on. I know there was a Twitter campaign for a while and trying to get, basically letting people know what was happening, letting the industry know what was happening. We want to do these surveys. We're not going to impose any sort of sanctions on you if we find something. Let's identify the vessels. So we've identified, when we use marine traffic, we use Port Authority websites. We're liaising with fleet operators as well. We're also talking with the shipping agents when it actually comes time to intercept the vessel. That's the keystone right there, is if you can get in good with the shipping agents, they'll work with you and they'll help facilitate your program. If the shipping agents don't like you, it's not good. then we can do the survey. So great, so data collection is really easy. So I would send out an email and say that we've been engaged to conduct hull surveys. The department, they provide some nice introductory letters and a little information sheet on what the surveys were about. So I found a particular vessel. This one was called the White Kingdom. It was due in Geelong. It was actually due in Geelong on last week, and I was going to look at it on Tuesday. So I send them the email, all good, say, please note this survey is not for the purposes of compliance with any biofouling or other regulations. You can say that, fantastic. Get an email back, yep, that's fine, so it's all sweet, ready to go. So Tuesday morning, I catch the 6 a.m. flight from Auckland to get over here by 8:30, drive down to Geelong for about an hour, do the survey, come back here for the conference in the afternoon, the meeting in the afternoon. So I get off the plane. Well, the divers, I should say, are coming over from Mornington. So they mobilize, they take the ferry across Port Phillip Bay, they get into Geelong and do the survey. So I get off the plane at 8:30, check my emails, and this is my first email. This is from Port Control. So the vessel's gone. So call the divers, guys, cancel. Yes, I'll still pay your bill. It's okay. We did that quite a bit where we would find, we're all set up to do quite a few surveys, but they'd be canceled at the last moment. That's just the way it goes. Oops. Okay, so what did we actually find? Well, we looked at, to this point, the program's not finished. We've got 33 vessels complete. We've looked at vessels ranging in size from about 85 meters up to this one, 270 meters. Really stuck with commercial vessels, so just like Ollie was saying yesterday, bulkers, container ships, general cargo, break bulk, livestock carriers, passenger ships. We only got one of those. There's a story around that one. Where did these things come from? Well, China predominantly, Singapore, Indonesia, New Zealand, that sort of rounds out the top 4. Quite a few vessels work a particular transit route from the Pacific Islands, New Zealand, down the east coast of Australia. Pacific Islands, New Zealand, down the east coast of Australia. So there's a lot of vessels actually do these circuits where they're going around and around in circle. And sure enough, on some of these, like the vessels that arrive from New Zealand, they get into Geelong, do the survey. Oh, there's Ostrominius modestus, New Zealand. There are lots of New Zealand fouling on it. And we can start pulling out all sorts of information from the database itself in terms of what's actually there. So just the whole series of slides I've got now is just around the types of things we've actually seen. So how long has it been since the last anti-fouling coating? It ranged. We had a couple of vessels that were basically on their maiden voyage. So the time since coating was actually relatively short. These are just averages overall. I think the longest one was 5 years and 3 months since the anti-fouling coating. And surprisingly, that particular vessel didn't have the highest fouling rating overall. One of the things that we did see quite frequently, and it will be no surprise to everyone here, is that if you look at the wider hull areas, the fouling rating, the fouling load is fairly low overall. But as soon as you get around the niche areas, surprise, surprise, we're seeing lots of stuff. This was particularly a good one. The hulls and the sides, all the way back to, just into near the stern, were really, really clean. We're thinking even the gratings, oh, that's really good. Then we came around the turn of the boat, and we've got a marine reserve happening. This thing, I would probably provide some sort of, environmental protection to this because it had so many different species in one very small area. And we kept seeing it again and again and again. This was a good one as well. Lots of things happening on these vessels. So perhaps these ships aren't quite as clean as the operators are potentially saying. So if we look at the different types of vessels, we've got some bulkers. There's the fouling loads on the side. So we tended to we collected information on both the level of fouling and the fouling rating, as I said. We lean towards using the fouling rating more because it gives a little bit more, more detailed information than the level of fouling. But they both provide very similar information overall. So there are the bulkers, fouling ratings on the hull, the wider hull, down around 17.9. These are the average numbers. In the niche areas, 22.5. So lots more fouling in the niche areas than up in the main part of the hull. General cargo ships as well. This one in particular was a ship that was coming in from Denmark, and it was bringing in some turbine blades for a big wind farm that's being built in South Australia. Now initially we were a bit concerned in South Australia that we wouldn't get the level of international arrivals that we were hoping to get, and it turned out that it just coincided with the big infrastructure development on land, so that bringing lots of ships were coming in directly. So that worked out quite fortuitously, really. Container ships as well. Actually, for all the container ships we saw, they're coming directly from New Zealand. So again, it's that circuit. The islands, New Zealand, Australia, the islands, New Zealand, Australia. Fouling ratings on the hull, 24.6 on average, 37.1 in the niches, so a little bit higher. Livestock ships as well. Most of those we got up, I think all those actually we got up in Darwin. So again, it's a circuit. Southeast Asia, Asia, down to Darwin, and back up. All these ships are going back and forth. Over the space of the month, we would potentially see the same ships a number of times. So if we wanted to look at the increase in fouling on a single ship, it'd be easy to do it in Darwin. Except for the fact that you've got to get to Darwin, which is not actually all that easy. What's on board? Well, it's the standard level of fouling. We've got algae, the numbers have all disappeared. Something about taking a Windows file and putting it in a Mac, sometimes it just doesn't work. Doesn't matter. Algae are the biggest proportion, then you've got barnacles, polychaetes, bryozoans, bivalves, and there's other bits and pieces as well, as we all know. So there's no really big surprises as of yet. Look at the speed versus the basically the biofouling load. Obviously, you go faster when you don't have so much of a load. I'm just going to whiz through these really. Fouling coatings as well. Some coatings seem to work better than others in terms of how you'd relate the particular coating versus the fouling load, but that doesn't take into account the basically the time since it was actually applied. So you have to look at that with a grain of salt. Vessel types, same sort of thing. So we're getting reasonable levels of fouling overall across the different vessel types. Fouling loads by state. Again, these were basically the data collection happened in each of the states and the territories, so we can break it down to those different locations. I guess in my mind, you just clump it all together and work with the data. But again, once the statisticians start looking at this, there's really a lot of information they can play with. Likewise, fouling loads versus vessel location. The niche areas, again, they get by far the greatest amount of fouling. But you can actually look at the niche, the different areas, the discharge points, the docking block marks, the bow tunnel thrusters, the stern tunnel thrusters, all that sort of thing. Then one of the comments that came up yesterday surrounded, I think Sonia had mentioned it, like to know if there's, what effects biofouling management plans actually have. So I did this slide just last night. I said, okay, what happens? We've got, how many of these ships actually have biofouling management plans and how many don't? Well, 19 of the 33 had BMPs, 14 didn't, so it was a pretty, well, a reasonably even split. Range of the hull fouling rating for those that did have a BMP, 0 to 43. Range of the fouling rating that they didn't have a BMP, 1 to 47. Not really that different. Really what we're seeing is that if you've got a BMP, it doesn't necessarily mean that there's less fouling on your ship than if you don't have one. Now, one of the other potential things that popped up yesterday when Ollie was discussing is perhaps there's some relationship between levels of fouling and how long it's been since the last class survey. So I did this graph yesterday as well. It's not really a strong correlation between days since the last class survey and actual levels of fouling itself overall. Layup periods as well. How long has it been? How many periods of time has the vessel just been laid up, basically not operating its bed anchor for a period of time, versus the date since the last anti-fouling application and the fouling rating? As you'd expect, increase the layup periods, increase the time since the last anti-fouling application, and the fouling level rises. There's, again, no surprises. I'm not really seeing any major surprises in any of these. More port calls means probably more time that you've been since you've actually anti-fouled, higher biofouling loads as well. Oops, that's the port calls one. Source ports, so we can break it down into different source ports. Again, China, Indonesia, Denmark, because we had a lot of vessels going into Adelaide, particularly directly from Denmark. That was quite helpful. Fouling loads, so we can look at the fouling load in the hull versus the niche areas. So again, we're seeing there's just more fouling in the niches. So what are our take-home messages out of this? Well, this is a work in progress. We've still got 6 more vessels that we're going to do. We're really going to be focusing on arrivals to Tasmania because they've been difficult to track down to this point. Now, we did note that of the 33 vessels, a notifiable pest was detected on 1, and that was taken care of in another area. 2/3 of the vessels had a biofouling management plan. The LOF and the FR ratings, they give very similar level trends overall, although instead of here the fouling rating was somewhat richer in terms of the picture that it would paint of what's on the vessel itself. Roads, graves, and niche areas. Those niche areas on average had greater than 5% cover, and 2/3 of those vessels had niche areas that was greater than 5% cover. So those particular vessels, say 2/3 of the vessels, if that's indicative of the wider fleet servicing, say, in New Zealand, that's 2/3 of those vessels are going to fail the short stay criteria for the crafters management system. So does that mean that 2/3 of the vessels going to New Zealand shouldn't be going there? How do you actually deal with those? It's pretty tough. And again, maybe this data set can actually be used, as we suggested yesterday, to validate the MPI Cawthorne Indicators program that Ollie was talking about. I can't stop, of course, without acknowledging everybody that was involved. I mean, you've got a lot of people involved in it, all the dive teams that were there and really collecting really good information for us, and of course the department itself for funding the program. And that's it. And I didn't see anybody fall asleep, so fantastic.